Okay, so yeah, let's start our lecture today. So, um, okay, so last time we mentioned that, so here, so this is the domain space, and then we pick a point, z naught, which is equal to x naught plus I y naught, and then we take it into break it down to intervals, right? So here, this point, we have x naught minus a half. Here we have x naught plus a half. And then the map exponential of 2 pi I z. Okay. So, and then the image, it will be, so let's say that here this is gamma. Then this is gamma of z naught here. And then, so which is a zeta naught. And then this is so this is the interval of actually open set u. Then okay, oops, I think so okay, so this is like this is actually the u. So this is like the yeah, so this is the set u. Okay, so this is set u, and then this is like the one of the kinetic component of the inverse image of this gamma. Sorry, inverse image of this u on the map gamma. Okay. So last time we defined a curve. Let's say t goes to z naught plus t, right? So we define a curve. Yeah. So sorry, we define a curve a small gamma. Oh, yeah. That's from 0 to 1 to this c, right? Yeah, so, and then, let's see, so, okay, so here, so the endpoint should be just x0 plus 1, right? So x0 plus 1 plus I times y naught. Okay. So this one is small gamma of 0, small gamma of 1. Okay. And then you let, okay, and then you let this gamma t to be equal to the small gamma of t to be the gamma of gamma tilde, small gamma tilde t. Okay, which is equal to so e to the 2 pi I times x naught plus t plus these I y naught. Okay. Okay, so then, so you can see that actually we can pull out the t, right? So which is, so we pull, after we pull out the t, it becomes e to the 2 pi I t, right? And then the rest is just the original x naught plus y naught, which is the gamma of z naught, right? Because gamma is exactly the map exponential to I z. So it is equal to the zeta naught, which is gamma of z naught times e to the 2 pi I of t. Okay, so yeah, so this is just you just like yeah, so this is just multiplied by an angle, right? So we just move like back and forth, like around. Yeah. So this is like the image of. Oh, sorry. This is like the gamma t, small gamma t. Okay. Okay. So now, okay. So I'm following the book here. So clearly, the map. Phi naught from z to z plus 1 is a deck transformation. Okay. So we have with an injective homomorphism from the integer z to the deck transformation group of gamma given by and n to phi n. Okay. Sorry, phi naught n. Okay. So where this phi naught n is the translation from z to z plus n. Okay. So let's check why the map phi naught is a deck transformation. So to check that, so namely what I want to do is that I want to see why if you compose the okay, so if you compose phi naught, so if you compose gamma with phi naught, then what you get is which is equal to e to the 2 pi I of z plus 1, right? Yeah, so which is equal to e to the 2 pi I z. Yeah, times e to the 2 pi I. Okay, so which is exactly the same loop. Okay. Yes. Okay. Okay, so and so clearly it is a homomorphism, right? Because it's continuous and then continuous inverse, and then okay, and then wait, what else do I need to check for the deck transformation? So yeah, I think that's it for the deck transformation. So let me check. This is calling space. Okay, yeah. So that's the yeah, and then we have an injective homomorphism. Oh yes. So because shoot. Okay, so because this C is simply connected, right? So therefore, it's a universal covering space. So therefore, by the theorem that we derived for the universal covering space, there is a wait. Oh wait. So okay. So I don't think we okay. So here So yeah. So since for so for each one you can also check, right? So because this is exactly the same thing as you replace 1 by n, so therefore you have an injective homomorphism from from Z to any from Z to the direct transformation group. Okay. All right. So okay, moreover, fiber gamma inverse of zeta naught is equal to Z naught plus C. Okay. So we also have selectivity. Okay. Yeah. So the fiber. Okay. So let's say if you have e to the 2 pi I, let's say for some numbers, let's say what is the number? Some value z2 了. Okay, so which gives you z naught, zeta naught, where okay, so Okay, so then, so let's break it out into z tilde minus z naught plus z naught. Okay. Okay, so which is equal to zero naught. So, because we know that e to the 2 pi r z naught is equal to zero naught, so therefore, and also the image is not equal to zero, right? So, yeah, so we are allowed to, yes, okay. So this implies that e to the 2 pi I, yeah, so e to the 2 pi I, yeah, actually, I don't think we need to say that it's not equal to zero because the equation will hold, yeah, it's equal to 1. Okay. So, yeah, so this means that, so this just implies that, yeah, so this implies that the real part of the z naught minus z, z tilde minus z naught should be 1, and also the imaginary part of z tilde minus z naught, which is equal to n. Okay. Yeah, so which is equal to n for some n in z. Okay. Wait, shit. Hold on. I think it must be equal to 0. Yeah. Because, yes, it must be equal to 0. So, so this implies that, so suppose that it's equal to x tilde plus I y tilde. Y is not 0. Okay. Okay, so this implies that x tilde is equal to 0. Sorry, x tilde is equal to x naught, and then y tilde is equal to y naught plus n. Okay. Yeah. So. Imaginary part. Okay, yes. Okay. So now, okay, so now by the theorem that we show that there is a bijection between the oh yes, So wait, no. The fiber. Yeah. So what is the space? We have selectivity. Yeah, I think this one is, yeah, so by the theorem that we established about the so we know that there's a bijection between, wait, yeah, between the fibers and also the deck transformation group. Okay. Okay, so and then for the universal covering space, so so wait, so we so selectivity the fiber is equal to okay, so oh yes, okay, yes. So because for each element for each element gamma in this for each element phi, right, in this deck transformation group, you can there's a unique element wait, in this one being identified as the phi of the base point, right? So where the base point is exactly the theta naught. So yeah, so there is a identification between the phi of theta naught to an element phi theta naught is an element in gamma inverse of theta naught. Okay. So actually we did sorry, yeah, from phi, yeah,